Okay, hello and welcome back. Today you are going to be looking at more on quantitative displays and what we've seen and describing and comparing them. So the major things that we use to describe and compare is that idea of cus, okay? So center, anything unusual, shape, and spread. Reminder, I'm here after school on Thursday. Your test is on Wednesday of next week, and make sure you have your calculator every day. Okay, so far, again, looking at the unit, what we've done so far, the mid-unit check-in, that's going to be when I get back on Thursday. So today and tomorrow is going to be doing a lot of learning goals 1 through 8. So we're going to be looking at box plots, stem and leaf plots, histograms, outliers, describing them in numbers, all of that. And then when I get back, you only need to learn one last thing. Okay, so just a reminder, today is meant to help you practice what you've learned so far in AP style questions. So that means at the top of this packet right now, you should be putting a lot of stars and you should be saying, okay, this is potential test questions. Consider this review for your exam. Okay, it contains really good, can't say this enough, multiple choice and free response. So what I'd like you to do is try these on your own, and what I'm going to do in here is explain my answers. I scan them in and I'm just going to talk through them. So you have this, it's going to be on My Big Campus. You can look at it at home, even if you're looking at it next week before our test. Okay, so number one is talking about, sorry about that, summary statistics for the amount of rainfall. So make sure you know your content. It's rainfall in inches. They give us the sample size, the mean, the median. We don't know what this is. The standard deviation. Don't know that. Our quartiles, our max and our min. So describe a procedure that's saying write down what you would do. So this is our procedure that we learned in class for testing for outliers. They're not asking you to actually test. Okay, so anything below that or higher than that is an outlier. So now it's saying, are there any outliers? So using my information from up top, I figured out my IQR. Using my quartiles, I got my fences to be negative 4.67 and positive 33.605. And then I said, yes, there is an outlier because our maximum is 38, which is above this 33. So I know that there's definitely at least one outlier. I can't say if there's more because I don't have all of the actual data values. It's important that you say that. You know that there's at least one, but there could be more. The news media reported that in a particular year there was only 10 inches of rainfall. And they're asking us to comment on that, comment on what this reporter said. So I said, well, our Q1 is 9.68. So 25% of the time, there's less than 9.68 inches of rain. So I say, okay, well, 10%, that means at least, I don't know, 25, 30% of the time you're getting less than that. So I didn't think it was that bad. You could have other arguments. You could say, okay, well, only 25% of the time. It really depends on you as long as you're justifying it and using the values above to help you. Okay, question 2. Another AP Stats question. This is talking about two popular gasoline additives, A and B. And what we're trying to do is figure out if these gasoline additives will help with the differences in miles per gallon. So what we're looking at is the distance traveled was recorded, and the difference in the distance with the additive minus the distance without the additive for each is calculated. So that might seem a little bit confusing to you. So what they did was they, same car, again controlling, they ran it without any additives and then with the additive to see what's the difference. How many more miles can we get basically? So we're talking about miles per gallon of this fuel efficiency idea in these gas tanks. So we're given values below Q1. So we're given some information, our quartile, our median Q3, and the values above Q3. So that means we don't know exactly how big this data set is. We just know that these are our absolute highest three, or sorry, lowest three and highest three values. And the reason why they gave us this little bit of extra information is so then if we do test for outliers, we can identify them. So I started by finding the IQR for each, separating my page and working with additive A first. The values I got for my fences here were, let's see, 3.5, negative 3.5 to 8.5. So then looking at our values up top, negative 3.5 or below, so that makes negative 8 and negative 10 an outlier. And then looking above 8.5, well, we have 9. So in this data set, there are 3 outliers. For additive B, however, when I do this, my range is negative 4.25 to 6.55. Looking at my max and my min for additive B, it's 40, and my min is negative 5. They're all within that range, so there's none here. So then we made what's called parallel box plots. So they give you the number line, and you have to label which box plot's on top. Okay, so I first began by making the box. I estimated where my quartiles and median would be. Then I labeled with stars my outliers. And then I went back and looked at my list for list A, and I said, okay, if this is an outlier and this is an outlier, then this is where I draw my whisker to. So that's why I drew my whisker to negative 2. Similarly, if 9 is an outlier, the next highest number is 7. So then I drew my whiskers in. For additive B, it was a little bit easier. I could just use my Q1, my median, Q3, and draw to my max and my min. Make sure they're labeled. So part B is asking you to interpret a little bit. In part I, it says, if we are trying to, which additive, A or B, would you recommend if the goal is to increase gas mileage in the overall highest proportion? So proportion is like percentage. So these quartiles give us an idea of, 25% lies above, 75% lies below. And if you think about that idea and you think about increasing gas mileage, that means that they want to be higher up on this number line. This is gas mileage. That's what this is showing. I said additive A, because if you look at additive A, and you look at Q1, that means 75% lies above Q1. That means 75% of this time, okay, they were going to increase fuel efficiency. Your 0 is your cutoff. If it's above 0, then that means they gained in fuel efficiency. So that's why I said, yes, there are these 2 cars down here that are outliers, and we definitely have another, at least 1. But 75% of the time you are increasing. Whereas for additive B, if you look at additive B here, the median is right here. So half of the time you're increasing fuel efficiency. Okay, Roman numeral part 2 here, or not Roman numeral, II here, is saying which additive A or B would you recommend if the goal is to have the highest mean? And well, then I'm thinking about the shape, and remember, outliers will pull sort of in that direction, so you're getting pulled down a little bit, and half your data is above this point. So in this case, I said, okay, B would be better, because it's going to be pulled up. More than half the data is above 0. Okay, some multiple choice questions. Consider the box plot. The distribution is skewed right. Again, measure from the median to your min, and the median to your max. And if you notice, this is then, it's longer on the left-hand side. So then it's skewed left, not skewed right. The IQR is about 8. So looking at the IQR, Q3 minus Q1, this is about 10. This is about 18. So that's correct. The median is about 10. No, the median's right here. So it's 15. Again, back-to-back stem and leaf plots with these Roman numerals. So we're looking at this. They didn't give a key, but if you read it, this is saying the number of books read by college and high school students. So this would read as 10, 10, 13, 15. This would read as 7, 16, 16, 13. Okay. So 7 college students did not read any books. No, they are just completely misinterpreting this 7. Okay. The median is equal to the high school median. The mean is greater than the median in both groups. So what I did was I plugged this into L1, and I did 1 var stats to figure out what the median and mean were, and I figured them out here. Same thing for this. I plugged it into another list to find the mean and the median, and that's what helped me answer these. The medians are both 24, so 2 is true. And then the mean here is higher. The mean here is also higher by a little bit, so that's how I got 2 and 3 to be true. Couple more AP questions. I said they're very good. Okay, so we're told here that we have a skewed distribution. It is strongly skewed to the right, so remember it has that shape. Okay, so why should we use the median instead of the mean? because of that skewedness. Okay, the mean is affected by the skewedness. The mean gets pulled up in this case. Okay, next one. We have a dot plot here. There's 28 residents on a street, and we're looking at the total number of miles that they travel to work every day. Which of the following is the closest percentile rank? Percentile measures the percent below. So I looked at 85. It's right here. I counted up the number of dots, counted all those up. I got 19 out of the total of 28 to figure out the percentile. It's closest to 70. Okay, last question is review. You still need to remember this. Okay, so if you read through this, there are 200 boxes, each have 25 controllers. The buyer numbers the boxes from 1 to 200 and randomly selects 6 numbers. Then those are the 6 boxes in which he examines all 25. So sum from all is stratified. If you picked that, you fell into the trap. This is all from some of the groups or some boxes. So that's what makes it cluster. Okay, good luck. I hope you did all of these and you studied them again before our test.